this is problem 2 of Neetcode 150's valid anagrams. First, what is an anagram? An anagram is a word that results from another word whose letters has been moved around. For example, Neetcode and teen duck. You can see that we only move the N and the T, and here we move the C and the D. So with the same letters, you can just rearrange the order and make another words. This is the concepts behind anagrams. For example, here you have car, you have rack, you have arc. You can see that you just move around the A, the C, and the R, and you make all these anagrams. A counter example is Walter and water. These are not anagrams because you need to add an extra letter to make the other words. So now that this is clear, we can jump into the code. How can we solve the problem? First, we can use the sorting algorithm, which is not the most efficient one, but it is probably the shortest one to write in code. We have to keep in mind, though, that if the length of the first string is then the same length as the second one, they cannot be anagrams. So this is the first check that we want to make. If the length of S is not equal to the length of T, we want to return false. Otherwise, we can start our algorithm of sorting. And with Python, it is so easy. You can simply use the method sorted. For example, here, letters has been sorted, and we can see that we have a nice array of the alphabet. Same with numbers. They're now in ascending order. So if you do this with both strings and they appears to be equal to one another, well, you found anagrams. So you're just going to return the sorted S equals sorted T, and this will work. The problem, though, with this technique is that each sorting takes a time complexity of n log n. So you're going to have n log n plus m log m for both strings. There is a better way to solve this problem. It is called the hash map. So what is a hash map? It is, you can see it as a dictionary. So you're gonna have each letters in the dictionary as a key, and you're gonna have the amount of times that it appears in the string. So example here for Neetcode, you're gonna go over the entire string, and first you're gonna see an n, so you're gonna add an n. And you're also gonna add a 1 for the count. Right? Then you're gonna see E. You're gonna add 1 as well on the other side. Perfect. And you're gonna see another E. So you're gonna increase the count. And you're gonna do that for all the other letters. So D. Right? And at the end, you should have a hash map that looks exactly like this one. So if we create a hash map that we call, for example, count 1, and we also do a hash map for the second letter, the second string. Well, to be anagrams, both hash maps should be exactly the same. So you should end up having something like this. Right, so if both are equals, it means that they are anagrams. If they are not, well, they are not anagrams. So let's code this now. We're gonna keep our same logic at first, that if the length of the first string is not the same as the length of the second one, we're gonna return false. And after that, we're gonna create our hash map. So let me say count s, count t equals, great. And now we want to loop over each characters of each string. So we're going to say for I in the range of the len of s, could be the len of t as well. And what we're going to do is that we're going to implement the value of count s to be basically the first character of s. So we're going to create the key, and the key is going to be equal to 1, but also as our previous example shows, if there is already a key, so for e, if there's already a count of 2, we don't want to just hard code the count to 1 here. So what we're going to say is that we're going to count s dot get, which is basically the same thing as here to the left, where we take the index of s, where whatever I is at this point. But the good thing with the get method is that we can assign a default value in case there is no key at this index. So we're gonna say count dot get si or 0, and we're gonna do the exact same thing for the count of t. Like this. And now once we run this code, we are gonna have our two hash map, and we can now return whether they are equal or not. So if I say return count s equal count t, we should receive true if we have 2 anagrams. Otherwise, we're going to receive false. And what is good with this method is that it uses a time complexity of n plus m, which is much more efficient than our sorting method that uses a time complexity of L log n plus m log m. I hope you learned in this video, and I hope to see you in the next one.